So hello everyone, welcome back to another particular lecture series of our asymmetric synthesis course, and this is lecture 3, and in this particular lecture we are talking about the generation of asymmetric synthesis. So from the very beginning, when the asymmetric synthesis has been introduced, from there till now, the frontier's time, there are many methodological advances has been carried out to streamline the asymmetric synthesis process. And this biggest roadmap from the beginning till now, the current research area, this particular roadmap can be classified with different generation of asymmetric synthesis based on the how the scientists, the people approach the asymmetricity on the particular synthesis pathway. So this can be classified in the four different broad generations. The first let us discuss in the next slide. So the first generation, where in the beginning uh, how they incorporate asymmetricity, they use stoichiometric amount of a chiral compound which uses a substrate. This particular chiral compound can be used as a naturally occurring chiral compound that is easy to extract. For example, they can start from amino acids and all, and they use that particular amino acid which had a particular chiral center. Okay, and from there they will do some kind of functional group transformation to form a desired enantioselective selective product, and this particular methodology is called the chiral pool synthesis, and we will discuss in the subsequent slides this all. The next generation said the auxiliary based asymmetric synthesis. This is a method where a chiral auxiliary is covalently attached to the substrate, and through it controls the asymmetric induction. That means suppose you have a substrate. Now that particular substrate has introduced a chiral part, so that that particular chiral part can influence the particular transformation via asymmetric route, and after getting the desired final product, that particular chiral auxiliary part can be removed. So this is called the auxiliary based asymmetric synthesis. This has certain advantages over the initial approach, but it also has certain disadvantages. Okay, and this auxiliary based asymmetric synthesis, you can find similarity with the protection deprotection group. The third generation of asymmetric synthesis, it deals with the chiral reagent, which controls the asymmetric synthesis. That means the particular reagent, such as metal based reagent, which contains a chiral ligand, that particular chiral ligand will provide a chiral environment in the particular reaction mixture. For there, it will provide asymmetric product in their final compound. So, and this is the chiral metal reagent. For example, bienol based ligand, you know, that particular bienol based ligand are actually provide a asymmetric induction to the particular substrate, so that it will form a particular chiral product. And the fourth and the state of the art uh, methodology, that is a current methodology, that is a chiral catalyst control asymmetric synthesis. Here not a chiral reagent has been used, a chiral catalyst has been introduced, which chiral catalyst temporarily bind the particular substrate via hydrogen bonding and some kind of weak interaction, and give a asymmetric pathway, or block some kind of area, so that the nucleophile or some kind of the other reacting partner will only able to come for attack in the certain direction, which actually leads the asymmetric product. So this is the broad four generation, and we will discuss all four generation subsequently. So first discuss the chiral pool part. So as I already discussed, that the chiral pool synthesis, which refers a synthetic protocol which employs a chiral starting material in the synthesis of a target molecule, and this is also known as Chiron approach. That means you start with a chiral compound and ended up with a chiral compound via some kind of functional group transformation. Okay, now As I already discussed, that the chiral center in the starting material mostly preserved in the target molecule or product, and this particular new chiral center can be generated through substitution or addition reaction, and the modality of the reaction, as I discussed, functional group interconversion or substitution reaction. Now what will the starting material of this chiral pool synthesis? The starting material of the chiral pool synthesis is mostly naturally occurring amino acids. Let us understand this via an example. So you can see that the chiral pool synthesis example, formation of L-glyceraldehyde from L-serine via FGI approach. Now this is S-serine, that is a naturally occurring amino acids which had a preserved chiral center here, and the configuration is S. So it will go via functional transformation to form the L-glyceraldehyde, where you can see that this particular chiral center maintained. Now how can you do the transformation? First, using the diazotization Na2HCl in presence of H2, it will form OH. Now you have to protect this particular diols first. So this particular diol can be protected by using acetone and PTSA, and followed by this particular acid moiety is there, and the classic simple reagent chemistry BH3 will reduce that particular acetic acid part to their corresponding alcohol, and then we use PCC to form this particular aldehyde. The oxidation of alcohol takes place, followed by the deprotection to get the L-glyceraldehyde. So this particular approach, you can find that particular chiral center is already there. We just do functional transformation to get another different product. Similarly, in another example, you can find that formation of D-alanine from L-lactic acid via substitution approach. How? First, this particular OH getting protected, the acetic OH, by the benzyl bromide, followed by this particular OH can also getting protected by tosyl chloride to form the OTS. It is a good leaving group, and azide has been attacked via a nucleophilic substitution reaction, that is the SN2 reaction. Now you can see that particular stereo center getting changed, and after that the H2PDC will do the reduction as well as the deprotection to form the D-alanine part. So you can find that how beautifully they can design by taking a simple naturally occurring chiral compound via functional group transformation to their desired product. Now you may think that okay, this is very easy, this is very sustainable, but no, this particular process has certain advantages and disadvantages as well. So let us talk about advantages. You all know that a simple functional group process, but the disadvantage is that this transformation is required stoichiometric amount of chiral compound for the conversion, and you know that particular chiral naturally occurring amino acid or whatever this chiral compound, this is costly because of the stereo center. Okay, so this is not sustainable in the industry scale. Obviously that in initial stages of asymmetric synthesis, they use this particular pathway, but this is not a scalable pathway. And also the another problem is this is the multi-step synthesis, which you for that particular reason you have to think so much to do this type of functional group interconversion, and also tough to find the suitable chiral starting materials, because in naturally occurring chiral compound, they are limited chiral compound like amino acids, pools and some kind of there. So it is very hard to find the suitable chiral starting material for designing or generating product, and also it is hard to maintain the pre-assigned chiral center during multi-step synthesis, because if you use any kind of different reagent, then it may be alter or destroy the particular chiral center that you want to preserve. So this is the main disadvantages of the chiral pool synthesis, and that's why the researcher are moved to this particular generation to a different approach, and this particular approach is called the chiral auxiliary based approach, and this is the generation 2 of asymmetric synthesis, and this will discuss in our next class. So next class we will discuss about the chiral auxiliaries and chiral reagents together, and in this particular class I will discuss about the generation as well as the chiral pool synthesis. I hope that you will learn something. So we'll meet on next lecture. So thank you for listening.